Hi, good to see you again. Welcome to Block 5, Addition and Subtraction of Fractions, Lesson 10. I'll share my screen. So, in your previous lesson, you learned how to add and subtract improper fractions and mixed numbers. In today's lesson, you're going to learn how to use fractions in algebraic context. So it's getting a little bit challenging, but don't worry because all this while, all the knowledge you have acquired, you're going to put it to use to start to push things a bit further, to deepen your understanding of mathematics. But remember to like the video, subscribe to the channel, share the video with those you think can benefit, and then click on the notification bell so that when new videos are released, you will be notified. Thank you. Before we start, I would like you to pause the video and answer the retrieval practice questions in 3 minutes. Assuming you've paused the video and you've answered the retrieval practice questions, here are the answers. Let's discuss them. So for the first one, I think you noticed that this is a linear sequence. You can see that between 1 and 6, the difference is 5, and between 6 and 11, the difference is 5. So it is changing by the same amount every time, and that is what defines a linear sequence. A linear sequence is a sequence that is increasing or decreasing by a constant difference, or if we use it in everyday language, the same amount. In this case, we see that it's changing by 5/7 every time. Okay, so the denominators are the same, 7, so we're simply just adding 5 to the numerator. For this one, I'm sure you remember how we solve equations. To solve an equation, our aim is to make the x stand on its own. The thing that is preventing the x standing on its own so that we can have x equal to a value is subtracting 7.9. Well, to get rid of it, we have to do the inverse of subtracting 7.9, which means we have to add 7.9. But remember, whatever we do to one side, the left side of the equation, we have to do it to the right-hand side of the equation. So in this case, we'll have 12.7. Next, we're asked to find the value of t squared minus 3t when t is 7. So if you recall this, we did something like this in our lesson on substitution. So we're going to substitute wherever we have t, we're going to put 7. But remember, we're squaring t. So t squared means 7 squared. And then minus 3 times 7. 3t means 3 times t. Okay, so now 7 squared means 7 times 7. So 7 times 7 is 49. So you have 49 minus 21, which is 28. Let's do a new learning for this lesson. If I ask you to work out the missing number, what would you say it is? Of course, you would say it is 5/7. Now, before I go any further, I want to give you a glimpse into what we'll be discussing because it will help you understand this much quicker and better. I want you to take note that in maths, things we don't know, we usually use letters to represent them. So this question could have been written as 1/7 plus A equal to 6/7, or 1/7 plus B equal to 6/7, or 1/7 plus a question mark equal to 6/7. But in maths, we use letters. So take note of that. We can use a bar model to represent the same thing because what it means is that 1/7 adds something, and you know in a bar model, we usually add the bars. So 1/7 adds something is equal to 6/7. So that is what is represented in a bar model. So to be able to find this that we do not know, it's a bit like saying, right, let's slice off this bit from 6/7, and whatever is left will have to be this. So, and that is what is represented by 6/7 minus 1/7. and that should be 5 over 7. Now, I'm going to show you different equations that seem to be the same as this equation you see here. And then you would see that we're actually just doing the same thing, but we've just represented it as a bar model. So here is what I told you. This is exactly the same as what we saw above. We've simply represented the box with a letter. So remember what I told you in maths. What we do not know, we represent it with a letter. So that letter X could have been A, B, C, D, E, Z. Who cares? And we could have written it like this. Why? Remember that addition is commutative. Commutative means swapping these around does not affect what it's going to do or the result. It could also be represented like that. Okay? So it's simply been moved to the other side. The 6 over 7 has been moved to the left, and the x add 1 over 7 has been moved to the right. But it's just a different letter. And it is also the same thing as this. So this is after we have finished solving the problem. So that box could be X or it could be M. We'll get the same result. Now, let me just explain really quickly what we would have done if we're solving equations. I think you should know what we will do because we want X to stand on its own. We want to get rid of 1/7 because that is what is preventing X from standing on its own. So we'll still do subtract 1 over 7, which will get rid of that, and we'll still do subtract 1 over 7 on the right-hand side, which will give us this. So all these, this could have been X or M, and we'll get the same result. This is the same thing. So we could do subtract 1 over 7, and remember, we have to do it to the right-hand side as well. And that will give us exactly the same result. And we could do it the same here. We want the M to stand on its own. Subtract 1 over 7 and subtract 1 over 7. Okay. What about this one? How would we solve this problem? So we're going to represent it using a bar model, and then we'll talk about doing the same thing, solving equations, because we've learned this skill, so we're going to put this skill to use. Now, remember, we have something we do not know. So what are we going to put in the box if we were going to solve this like an equation? Have a think. What do you think we would do to find the missing value in the box? Of course, I'm sure you thought about it. We would simply do, if we represent it, we would simply do this because it simply means something subtract 2. So that thing has to be really big, a bigger bar, subtract 2, add 4/5. So subtract 2 will give us 4/5. And that can be represented as a bar model. And that will be 6, 1 over 5. Now, if we were to solve this as an equation, because I really want you to understand what is going on, remember, we did not know this, so we could call it X, Y, Z, A, B, C. Who cares? Now, the thing that is preventing the X from being on its own is the subtracting of 2. Now, to get rid of that, we have to add 2 to both sides. And you can see that will get rid of that. You can see why this will be 6, 1 over 5, because 2 is a whole number. We can add 2 to the 4 to give us 6, and we'll have 6, 1/5. If we have this one, we can represent this in a bar model. So it's a bit like saying 7 minus x will be equal to 638. So 7 has to be the big bar. And then it means x add 638 should be equal to 7. Now, that is how we can represent it as a bar model. But I want to tell you that, okay, if we wanted to find x, it means we have to subtract 638 from 7, because if we take that slice off, whatever is left will be x. Okay? So if we take that slice off from 7, which is equal to 638, whatever is left will be x. But let's solve it using algebra, how to solve equations. Now, we want x to be on its own, but take note that we always consider the sign next to whatever we're doing. When we're dealing with variables, we always take the sign next to it, to the left of the variable. Now, we want positive x, not negative x. So, but let's isolate negative x and see what happens. If you think about it, we're going to have to subtract 7 from both sides, which makes things a little bit strange. We say, right, I actually need positive x, not negative x. So what happens then is if we exchange and say, if I actually need positive x, then if I make x positive, it means when I do this subtraction, I'm going to get a negative answer, because take note that 638 is actually less than 7. But following the rules of knowing how to solve equation, we will have negative x equal to a negative answer. Okay? Now, because we're actually looking for a positive answer, our answer will change because we need positive x. So x will have to be 5/8. So that's another way of thinking about it. I want to show you how to do this now, because in future lessons, we'll use this skill. Okay, let's look at this. If we are asked to work this out, to work out the value of this expression and give our answer as a mixed number, you know straight away that you're doing substitution. So wherever the m is, you're going to put 3. Okay, that's what it means. Wherever m is, we're going to put 3. Now, if you do that, that gives you this. Okay, it's simple substitution. You now have 7/3 plus 2/9. Do you recognize a fraction like this? You can see that they share a common multiple of 9. So we'll have to make that one an equivalent fraction that has a denominator of 9. So of course, we'll have to multiply by 3. So that will be 21/9 plus 2/9. And that will give us 23/9. If we change that to a mixed number, that will be 2/5/9. Okay? How do we do that? In case you've forgotten, 23 divided by 9 is 2. We can only have 2 lots of 9 from 23. Why? 9 times 2 is 18. So we can only get 2 lots of 9. So our remainder will be 5. So the answer will be 2/5/9. Here is another one, but this time it is subtraction. So we're going to do our substitution, and we'll do exactly like we did before, which will give us 21/9, but this time we're subtracting. So our answer will be 19/9, which is 2/1/9. It's now time for you to practice what you've learned. Pause the video and answer questions 1 and 2 in 4 minutes. Assuming you've paused the video and you've answered questions 1 and 2, here are the answers. So here you simply ask to work out the missing numbers. So remember what we've done. You could do this simply as, use x as the missing value if you wanted to, but we're doing the inverse operation. So this is simply saying 5/8. To get this is 5/8 minus 3/8. Okay? 5/8 minus 3/8. So this is a mistake here. Not a mistake, because 5/8 minus 3/8 will be 2/8, which if you simplify will be a quarter. So that's correct. Then this one, you're simply doing the inverse operation. Remember? So you subtract. So let me write them out. I'll just write them out and then you can work them out later. So inverse operation minus 3/8. So imagine that these were x's. Yeah? Imagine that these were unknown as x. I want you to think like that. Think algebraically. Okay. So let's do this real quick. So we'll do the inverse operation, minus 1 over 4. So this is like saying minus 1 over 4, which will be 2 over 4, which if you simplify will be a half. Here, we'll do minus 3, okay, because we want the x to be on its own. That's gone. And then minus 3 whole, remember it's 3 whole, we'll be left with 3/4. Here, remember that calculation we did before. If you do subtract 5, you'll have a negative answer. But remember, you are interested in the positive answer because you don't want the negative x. So in this box, it should be 1/6. So it's like saying, 5 minus 4, 5 over 6. Okay. So I'm not going to go into detail because I don't want the video to be too long. You can work this out by yourself. By now, you should know how to do this because this is what we did in our previous lesson. Next, you were asked to solve the equations. So, you can see now these are the equations. So we have to do minus 3 on both sides. You can see why that is 2. Here we'll do minus 3 on both sides. You can see that why that will be 2 1/3 because 5 whole minus 3 should be 2. Here you can do add 3 to both sides. Can you see that I'm doing the inverse? All the time I'm doing the inverse. Okay, and that should be 8 1/3. Let's do the inverse here. We have to add 3 to get rid of that one. And that will be 9 1/3. Pause the video and answer question 3 in 2 minutes. Assuming you've paused the video and you've answered question 3, here are the answers. Let's discuss them. Here you can see you were asked if x is 2, work out the value of this expression. So you simply substitute in 2 for x. So wherever you see s, you put 2. So this will be like saying a half plus 3 2 squared. Okay, so it's a bit like saying a half plus 3/4, which will be 1 1/4. By now, you should know how to do that. I'm not going to go into detail. This should be 7 over 4 because 2 squared is 4. So 7 over 2 squared, subtract 2 over 2. So it's a bit like saying 7 over 4, subtract 1. Okay? So, and then this one is like saying half plus a half, which is 1, plus 1, which is 2, because 2 over 2 is 1, plus 5, that will be 7, and that will be 7 1 over 7. So really straightforward calculations. Here, question 4, you were asked, substitute the values g equals 4 and h equals 3 into the expressions. Give your answers as improper fractions. Okay, so pause the video and answer this question in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So this is for 4a and b. So you're simply doing your substitution. So g is 4. So it's a bit like saying 4 add 1/4. Okay, 4 add 1/4, which will be 4 1/4. Of course, if you make this a top-heavy fraction, you were asked to make them improper fraction. 4 times 4 is 16. 16 add 1 is 17 over 4. If you do your substitution here, this will be 3 add 1/3, which will be 3 1/3. If you change it to a top-heavy fraction, that will be, or improper fraction, that will be 3 times 3, 9. 9 add 1, 10. Then this one is a bit like saying 1 add, g is 4 over 3. Remember, 4 over 3, if you change it to a mixed number, or if you were to do this, if you add this, this is a bit like saying 1 4/3. Okay? So if you were to do this, you can simply say 3 times 1 is 3, add 4 is 7, so 7 over 3. And then this is 1 add, h is 3, and G is 4. So 1/3. Okay, 1/3. So if you were to change this to a top-heavy fraction or improper fraction, that would be 4 times 1, 4, add 3, 7/4. Then which answer was greater? Will this be true for any values of J and H? You can discuss that with someone else. Here is part C. Okay, the substitution is the same, and I'm not going to go into detail because I don't want this video to be too long. Okay, let's move on to the second part of our lesson. Remember what we're learning using fractions in algebra context. How often will this sequence produce integers? Well, by now you know how to use a sequence to produce numbers. So first, if we want the first term, we'll say when n is 1, we substitute 1 where we have n. Remember, 3n means 3 times 1. So it will look like this. 3 times 1 equal to 3/5. So the first term is 3/5. The second term will be 6/5. The third term will be 9/5. And the fourth, fifth, and sixth term will be these numbers. But have you noticed that the fifth term gives us an integer? An integer is a whole number. But they're asking us how often will the sequence produce an integer? Well, we do not really know, but can we make some conjecture or some projection? Well, we can do that by saying, what if the multiples of 5 would produce integers? So we can say, well, let's try 10 and see what we get. So you try it and see what you get. Well, that's interesting because we have an integer. So I want you to take really careful note of this problem because there is a question you're going to see where you apply this knowledge. Well, maybe you would have tried 15 and you would have noticed that that gave you an integer as well. So we can conclude that this sequence will produce integers on every term number that is a multiple of 5. It's now time for you to pause the video and answer question 5 in 6 minutes. Assuming you've paused the video and you've answered question 5, here are the answers. So question 5, A, B, and C. So let's look at A. You were asked to write the next 4 terms of the sequence. Of course, to write, so we have the first term, the second term, the third term, and the fourth term. So to get the fifth term, we'll simply say 5/3 because we replace the term number, we replace n, we substitute n with the term number. The sixth term will be 6/3. Have you noticed that 6 divided by 3 is 2? So we have an integer there. The seventh term will be 7/3, and so on and so forth. Okay? Now, we're being asked how many of the terms in part A are whole numbers. Of course, it's just 1. Okay? Next, you're asked which term will produce 5 2/3. We can't answer that question until we convert this, because have you noticed that this is the 5th term, 6th, 7th, 8th. So notice the pattern. The term number is what is in the numerator. So, well, let's convert this and see what it gives us, all right? So 5 times 3 is 15, so we're converting it to a top-heavy fraction. 5 times 3 is 15, plus 2, which is 17/3. So the 17th term should give us this number. Well, let's answer question D. We're asked how many terms out of the first 100 terms will be integers. Well, if you notice, when we worked this out, we noticed that the 6th term here, the 3rd term was 1. You see, did you see that? The 3rd term was 1, all right? Because 3 divided by 3 is 1. The sixth term was 2. So notice that the multiples of 3, because this is the third term, and you can see the sixth term, that is a multiple of 3. So the multiples of 3 seem to be producing the integers. Now, if you think about it, the numerator is giving us, so each time the numerator, so if we are on the 100th term, we'll have 100 over 3, okay? If we are on the 99th term, we'll have 99 over 3. Now, the last term we can get is 99 over 3. So there are only 33 terms, and if you notice, okay, so there are 33 terms that will be integers because this will be the 33rd one. Okay, because if you notice, if you go back, you would see that that gave us the second one. Okay, so it's each time we divide the numerator by the denominator, it tells us the position of the term that is the integer. So this is the second one. So by the time we get to the 99th one, it will give us the 33rd term, which is the integer term. Next, for E, you're asked, how often will the sequence 2n divided by 3 produce integers? Well, every third term will produce integers. So you could work this out to see that every third term will produce integers. So the first one will be 2 times 1 divided by 3, which is 2 over 3. The second one will be 2 times 2 divided by 3, which is 4 over 3. And the next one will be 2 times 3 divided by 3, which is 6 over 3, which is 2. So every multiple of 3, every third term will give us an integer. And next you ask, how often will the sequence 3n over n produce integers? Of course, every term will produce integer because 3 times 1 divided by 1 will be 3. 3 times 2 divided by 2. Okay, so the n will simply cancel out each time. And so we will produce an integer every time. Pause the video and answer question 6 in 4 minutes. Assuming you've paused the video and you've answered question 6, here are the answers. So question 6, A and B, you were asked to solve the equation. Now, have you noticed we want x to be on its own? So really, if we want to do this, we'll have to, work this calculation out. So first, if we do we do a common multiple, that one should be 6. So we'll multiply that by 2, and we'll multiply that by 2. So this is like saying x, add 4 over 6, subtract 5 over 6. Now, you're going to have a negative number, okay, which will be 1/6 because we know 4 minus 5 is negative 1/6. So it's like saying x minus 1/6 equal to 0. But remember, we want x, so we have to add 1/6 to both sides. We want x to be on its own. And then 0 plus 1/6 will be 1/6. So you can see why that answer will be right. Here, remember, to solve the equation, you have to make x be on its own. So the inverse will get rid of adding 1/5. So we do minus 1/5 on the right-hand side and minus 1/5 there. That's now gone. So the problem we have to deal with is to find x, we have to do 5 over 2 minus 1/5. Okay, now we need a common denominator, so which means we need to multiply by 5 to make that 10. We'll multiply that by 5. We'll multiply this by 2, and we'll multiply this by 2. This gives us 25 over 10 minus 2 over 10, which gives us 23 over 10. And if we divide 23 by 10, we'll get 2 whole number, remainder 3. And you can see why our result is 2. 3/10. For question C, this calculation is simply a case of working with the common denominators. So for this one, we can do the left-hand side first, which is to make this 56. We can simply multiply that by 8 and multiply that by 8. But another way we could do it is to make this, is to subtract. So subtract, convert this to a mixed number, a top-heavy fraction. So this will be 5/2. So if we rewrite this, this will be 2 times 2, which is 4, add 1, so 5/2, okay? Now, if we subtract 5/2 from both sides, we can then have a calculation for us to work with. So I'll leave you to do this. Okay, I don't want the video to be too long, but when you finish, your answer will be this. So you could do this. When you work this out first, you can then subtract 5/2 from whatever result you get from there. This one is a case of bringing things together that are similar, okay? So the first thing I would do is I would, on the left-hand side, I would subtract 586 from both sides. The reason I'm doing this is because you can see 7 and 14, they share a common multiple. So I will subtract 586/14 from both sides. So that gets rid of that one there. So I'll have 300. So remember, I have to subtract it from both sides. So I'll have 300/7 minus 586/14. Okay? So I'm rearranging it now. Plus x, the x is still there. All right? Minus 1/3. Okay? Minus 1/3. Equal to 4/6. The next thing I'm going to do is, remember, I need to make this equivalent. So I'll multiply that by 2 to be 14, and I'll multiply that by 2 to be 14. So I now have 600 minus 586. Okay? 600 minus 586. So when I finish that calculation, I would then add, okay? I would add 1/3 to both sides so that this should not be here anymore. And then this should be plus 1/3. Okay. So I'll now have, when I finish, 600 minus 586, I think that should be 14. So I'll have 14/14, which is a whole. Okay. And then when I finish, I would subtract whatever I get from here from both sides. Okay, whatever result I get from here, I would add or subtract, and then that will give me x. When you finish this, your value will be 0. Well done for sticking around and for working with algebra using fractions in algebra context. This is the beginning of building a really solid advanced foundation in your understanding of maths at a deeper level. Well done for sticking around and for taking this seriously. You may go through the lesson again if you did not understand this very well. Again, well done, and thank you for sticking around and for taking your learning seriously. Until next time, take care and bye-bye.